Hey y'all, and welcome to week 8, or the last week of this week's episode of Will She Burn Her House Down? Most likely not, because this experiment is fairly safe, but there's always time to find out. Anyway, in our final interactive discussion, we will be doing an experiment in which we make kinetic sand. Now, what does kinetic sand have to do with chemistry at all? Good question. So basically, kinetic sand, I don't know if you've ever played with it. Honestly, up until this experiment, I had never played with kinetic sand. Like, I saw all the commercials and stuff, and like, you know how they make the little ASMR videos. Like, I've seen it from a distance, but never actually like thought about it. I'm just like, oh, cool, sand you can cut through. Fun, moving on. So, what is kinetic sand? Kinetic sand is kind of like a fusion of like silly putty plus beach sand plus oh, what is that stuff called? I don't know if you guys remember that experiment that we did like way back when, like as kids. Might have been in high school, might have been in elementary school, not sure. But basically, you put cornstarch in water and you kind of just play around with it, and it kind of makes like this. It's not quite silly putty where it's not liquid, but it's not solid. But like if you pick it up, it falls apart. If you put it together and you form it, it actually will like form little balls. Or if you push against it, it becomes solid. That kind of thing. So it's a fusion of silly putty. I think it's called oobleck. Yeah, silly putty and oobleck combined into one substance plus sand is what it is. So in essence, kinetic sand is considered a non-Newtonian liquid, and so basically that just means that it's a suspension of sorts, mostly a suspension of sand into a liquid polymer. So not really an actual solute, because we're not dissolving our sand particles, we're literally just holding them together using a polymer. And I want to say it's like a silicone based polymer. What is it called? Yeah. So the polymer, the name of it is polydimethyl siloxy. So yeah, it's a silicone based polymer, although the majority of what makes up kinetic sand is still obviously sand. It actually takes very little of this polymer to hold the sand together, and you'll see in just a minute when I actually start making the sand. So let's get into it. So as you can see, I already have a good assortment of items gathered here right now. So what we have for this experiment is we have cornstarch, like regular cornstarch that I got from Walmart, some turquoise colored sand, and I literally just bought this from Hobby Lobby, so just regular sand. We have liquid starch and some Dawn dish soap. And honestly, most of this I had in my house already, so I really only had to go out and buy the sand and the starch. And honestly, the fact that I even had Elmer's glue in my house was surprising to me, but some regular plain Elmer's glue, to which you can see I already took the lid off because I like to live life dangerously. Anyway, so what we're gonna do is I'm gonna take this bowl, clearly empty, right? It's empty. And I have a little, technically this is a little dessert fork, but I'm gonna use it for mixing purposes, okay? I have this teaspoon a separate teaspoon, and then I'm going to be using this 1/4 of a teaspoon. I don't know if you can see that so well, but this is a 1/4 of a teaspoon. Actually, joke's on me, that's half. So I'm going to be using this 1/4 of a teaspoon as well. And so how we are going to be making this is I'm going to take 1 teaspoon of water. One of the actual most important ingredients in this experiment, water, even though you don't need that much of it. So I'm going to take 1 teaspoon of water and not go too crazy, hopefully. So 1 teaspoon of water and dump it in the bowl. About five-ish drops. 1, 2, 3, 4, no, 5. And then I'm going to take 1 teaspoon of cornstarch. And then 2 teaspoons of this white Elmer's glue, which I don't know that it specifically needs to be white Elmer's glue, it's just what I got from the store. Then just kind of scrape some of the excess in there to make sure I get all of it, or as much of it as possible. And then I'm going to take my 1/4 of a teaspoon and my liquid starch, and I'm going to fill up the 1/4 of a teaspoon, but I'm not going to use all of it initially. So I'm going to fill up 1/4 of a teaspoon of liquid starch, and I'm going to pour about half of it in here. Yeah, about half. Set that to the side, and I'm going to start mixing things together. So as you can kind of see, I'm kind of already starting to get this like congealed, almost putty-like texture. So now that I have this texture in my mixture, I'm going to go ahead and start adding sand. And this is where you get the more, the less scientific part of this experiment. Because while I did measure out the other materials, this is where I kind of just go with what I feel in my heart. And it ends up being maybe like half of a cup of sand, I think. But again, no exact measurements were done with this. So I'm just going to start adding sand, and I'm actually going to use quite a bit. So stop there and start mixing. Definitely nowhere near enough sand. So more sand. that might have been overboard. Okay, so I have some clumpies forming here. So now I'm going to go ahead and add in the rest of my starch. And now I'm just going to keep mixing on faith alone at this point. Okay. And here we have it. We have our kinetic sand. So you can kind of see where it's like falling apart, but at the same time, hold on. If I pick it up, I can still form it. And again, the reason that I can still shape it like this is because of the hydrogen bonds in the polymer holding it together. So I can still form it, but then as soon as I take pressure off and I just kind of let it go, you can see where it kind of starts to just pull apart. And honestly, I'm going to hold it a little bit closer just so you can see, and the more I mix, the better it's coming out. So you can kind of see where it's like combination of like slime slash silly putty slash sand slash oobleck. So again, you can form it, it takes shape, and you can squish it, but it'll also like fall apart when you stop putting like a ton of pressure on it. And again, this because of those hydrogen bonds. So the reason why you can like cut through kinetic sand is because hydrogen bonds can be strong when force is applied, but also still fairly weak bonds. And so the more shear force you apply, I know we haven't necessarily started discussing any principles of physics, but basically for every action there is an equal and opposite reaction. So for the amount of force applied is the amount of resistance you get from this kinetic sand. But yeah, and honestly at this point now I'm just being entertained by it. But yeah, so this is my kinetic sand, and I know the directions or the ingredients were a little bit different in the video and on the website. Honestly, I just kind of did my own research a little bit because I just really wanted something that would come out with similar consistency as real kinetic sand. And just because also I'm me and I wanted comparison's sake, I also bought some already pre-made kinetic sand just so that I could have like my own personal texture comparison. So yeah, but this is the final product. We have our kinetic sand and a little bit of a mess, but it's a good mess. So that's it for this week and also this class. Again, if you have any questions, comments, concerns, feel free to leave them in the comment section below, or, you know, as the professor of this class, you can just leave a comment and on Canvas. But happy end of this 8-week cycle, and to anyone else, good luck, live long and prosper, and yeah, I'm done now. Okay, well, I have a final to take, but then I'm done. Bye.